Welcome to Astronomy Daily, your source for the latest space and astronomy news. I'm your host, Anna, and today we'll be covering a range of exciting topics from FCC's call for more competition in satellite internet to the discovery of a mysterious black hole. We've got a packed episode ahead, so let's dive right in. In a bold move, Federal Communications Commission Chair Jessica Rosenworcel is advocating for increased competition in the satellite internet market, taking aim at SpaceX's Starlink dominance. Starlink, Elon Musk's ambitious project, currently controls nearly two-thirds of all active satellites and has launched an impressive 7,000 satellites since 2018. Rosenworcel argues that our economy doesn't benefit from monopolies, emphasizing the need to invite more space actors and companies to develop innovative constellations. She believes that competition in every communications market leads to lower prices and increased innovation, and space should be no exception. This push for diversity in the satellite internet sector comes as Musk predicts Starlink will deliver over 90% of all space-based internet traffic next year. The FCC is actively working to help new entrants navigate the Commission's processes and understand license application procedures. It's worth noting that this isn't the first time the FCC has challenged Starlink. Last year, they reaffirmed a decision to deny Starlink $885.5 million in rural broadband subsidies, citing failure to meet basic program requirements. As we look to the future of satellite internet, this call for increased competition could reshape the landscape, potentially leading to more affordable and innovative services for consumers worldwide. It's a space race of a different kind, and one that could have far-reaching implications for global connectivity. Next up in today's space news. In a groundbreaking discovery, Chinese researchers have uncovered a low-mass black hole that's breaking all the rules. This fascinating find is challenging our understanding of black holes and binary systems. The team, led by Dr. Song Wang from the National Astronomical Observatories of the Chinese Academy of Sciences, used a combination of radial velocity and astrometry methods to identify this elusive object. What makes this discovery so intriguing is that the black hole falls within what scientists call the mass gap, a range between 3 to 5 solar masses where black holes were thought to be extremely rare or non-existent. This particular black hole, found in the binary system G3425, has a mass of about 3.6 solar masses. It's orbiting a red giant star in a wide, nearly circular orbit that takes about 880 days to complete. This unusual configuration is puzzling scientists, as it doesn't fit with our current theories of binary evolution and supernova explosions. The discovery not only adds a new member to the known range of black hole masses, but also provides crucial insights into the dynamics of binary systems and stellar evolution. It suggests that there might be more of these low-mass black holes out there, hiding in binary systems we haven't yet detected. This finding opens up new avenues for research and challenges astronomers to rethink their theories about how binary systems form and evolve. It's a reminder that the universe is full of surprises, and there's still so much we have to learn about the cosmic objects that populate our night sky. Here's one for your calendar. Get ready for a celestial spectacle, stargazers. A partial lunar eclipse of the super harvest moon is on its way, and it's an event you won't want to miss. Mark your calendars for Tuesday, September 17th, when the moon will put on quite a show. This eclipse will be visible across most of North and South America, Europe, Africa, and parts of Western Asia and Antarctica. What makes this event extra special is that it's happening during a supermoon, which means the moon will appear slightly larger in the night sky due to its closer proximity to Earth. For those in the Eastern time zone of the U.S., the eclipse will kick off around 8:40 p.m. EDT and reach its peak at about 10:44 p.m. Our friends in Europe and Africa will catch the show in the pre-dawn hours of September 18th. Now, don't expect a total blackout of the moon. This partial eclipse will only cover about 8.7% of the moon's surface with Earth's darkest shadow. But even a slight lunar eclipse is a sight to behold. Can't see it in person? No worries. Several organizations are offering free online live streams of the event. You can tune in to Time and Date, the Virtual Telescope Project, or the Adler Planetarium for live coverage and expert commentary. So whether you're watching from your backyard or your computer screen, don't miss this super harvest moon lunar eclipse. It's a reminder of the wonders that unfold in our night sky. Now let's turn our attention to some concerning news about NASA. A recent report from the National Academies of Sciences, Engineering, and Medicine has highlighted significant challenges facing America's space agency. The report paints a rather dire picture of NASA's current state and future prospects. One of the main issues identified is aging infrastructure. Shockingly, 83% of NASA's facilities have exceeded their design lifespan. This isn't just about old buildings. It's about the critical technology and equipment needed for space exploration and research. Another major concern is underfunding. NASA's budget has remained essentially flat for decades when adjusted for inflation. It's currently hovering around just 0.1% of the US GDP, which is less than 1/8 of what it was during the Apollo era. This financial squeeze has led to a focus on near-term missions at the expense of long-term investments in infrastructure, workforce, and technology development. The report also points out problems with specific NASA resources, like the Deep Space Network, a crucial system for communicating with spacecraft across the solar system. This network is overworked and underfunded, leading to costly compromises in mission operations. The implications of these issues are serious. Without adequate funding and infrastructure, NASA's ability to carry out its ambitious programs in exploration and science is at risk. The agency that put humans on the moon and has sent rovers to Mars is struggling to maintain its technological edge. The report's authors present a stark choice: either increase NASA's funding significantly or cut some of its missions. It's a wake-up call not just for NASA, but for political leaders and the public. The future of American space exploration hangs in the balance, and the decisions made in the coming years will shape NASA's capabilities for decades to come. Let's shift our focus to something a bit more positive. In an exciting development, astronomers from the Nicolaus Copernicus University in Turin have made a remarkable discovery in the Great Bear constellation. They found a new planet that's pushing the boundaries of what we know about planetary systems. This newly discovered planet is a true giant, boasting a mass 11 times that of Jupiter. To put that into perspective, it's more than 3,000 times the mass of Earth. It's orbiting a star known as HD 118203, which is about 20% more massive and twice as large as our Sun. What makes this discovery particularly intriguing is the planet's orbit. It takes a leisurely 14 years to complete one revolution around its star, positioning it at a distance of 6 astronomical units. That's 6 times the distance between Earth and the Sun. The planet's surface temperature is estimated to be a frigid -100 degrees Celsius or lower, making it an inhospitable world despite its impressive size. This discovery is part of a larger planetary system that includes another gas giant discovered back in 2006. The two planets form what astronomers call a hierarchical system, with the inner planet orbiting closely to the star and the newly discovered outer planet circling the pair. What's fascinating is how this configuration challenges our understanding of planetary formation and evolution. The system's stability, maintained despite the planet's massive size and elongated orbits, is partly due to effects arising from Einstein's general theory of relativity. This finding opens up new questions about how such exotic planetary systems form and develop over time. It's a reminder that our galaxy is full of surprises, and there's still so much to learn about the diverse array of planetary systems out there. And that brings us to the end of today's cosmic journey through Astronomy Daily. I'm Anna, and it's been my pleasure to guide you through these fascinating space stories. Don't forget to keep exploring the universe with us by visiting astronomydaily.io. There, you can sign up for our free daily newsletter, catch up on all the latest space and astronomy news with our constantly updating newsfeed, and listen to all our previous episodes. Want more stellar content? Find us on social media by searching for Astro Daily Pod on Facebook, X, YouTube, and TikTok. Until next time, keep looking up and stay curious about the wonders of our universe. Thanks for tuning in.